Good morning from Toronto. My name is John Keogh and welcome to the Future of Food 2021. And we're kicking off the year with a mini-series on food provenance specifically. So we're going to talk to scientists about food provenance. What is it? What is it not? What techniques and technologies do we use to do it? Why do we do it? And what are the key challenges? And today I'm delighted to have with me Mark Hughes from Food Forensics in the UK. Good morning, Mark.
Good morning, John. How are you today?
I'm great. Now, Mark, I believe you are a sheep farmer currently in northern Wales. Can you tell us a little bit about you and then also about food forensics?
Yeah, sure. So I'll start with food forensics. I'm a technical services director for food forensics. So we, as a business, specialize in authenticity testing solutions, and particularly around stable isotope ratio analysis, but also we have a DNA lab. I also farm, as you say, in North Wales, predominantly sheep up in the mountains. So I probably experienced most sectors within the food industry, from agriculture right the way up to food retail, and have I would say a good understanding of the particular challenges associated with each of those kind of business areas.
Fantastic. So always great to talk to someone who does this type of work for a living, professionally and also privately, being a farmer. So, Mark, what is food provenance?
Okay, so for me, food provenance is about the origin or source of the food material. So where it's grown or where it's been reared, not necessarily where it's been manufactured or processed, but where it's originally from. So a great example, as you raised my farming background, is obviously we produce Welsh lamb. Welsh lamb has to be born, reared, and slaughtered in Wales, and so that's a great example, really, of a food item kind of provenance and the things associated with that. Hopefully that answers the question.
Yes. So, Mark, what are the technologies or analytical science methods that are used to determine the food provenance of, let's say, a fruit or a vegetable, and can you do that with meat or fish?
Yeah, so absolutely. So the main technique that we use at Food Forensics to validate the origin of a product is stable isotope ratio analysis, or that we refer to it as SIRA. So SIRA uses it effectively collects and compares a fingerprint, an isotopic fingerprint from where the origin of the material is from, and you can test a product against a reference data set of samples of known origin in order to confirm your desired origin or not, as the case may be. And you're absolutely right. It works on fruit and vegetables. It works on proteins, and it will also work in fish, particularly where you are farming the fish. Okay, so one of the drawbacks, it won't necessarily work on wild fish because of the way the isotopes will be distributed kind of generically within oceanic water. But where you are directly influencing the isotopic profile through feed, say in a farmed fish environment, absolutely, it will do work for that.
So if I could break it down then for the non-scientists that are listening to us today, and we have thousands that are listening in to the different sessions. So if I break it down, we have soil where plants, crops are grown, and the soil is influenced by water, by air, and then those trace elements are absorbed by anything that grows in that soil, making a fingerprint between the soil and the specific trace elements that are present in that geographic region. Is that correct?
Yeah, that's absolutely right. And furthermore, anything else that's added to that crop. So for instance, in organic systems where you may only be using or you should only be using organic fertilizer sources, slurries and manures and things like that, then that will also contribute directly to the fingerprint of the product that's grown there.
So does that mean that the chemicals that are not natural to the area will also be absorbed into the plant or crops?
Absolutely. Yeah.
Gotcha. So Mark, what then, in your experience in dealing with customers, what keeps coming up as the key benefits for them in doing provenance testing? And could you give us an example of a particular product and a particular technique that's used to prove the provenance of that product?
Sure. Okay. So I think the challenges depend on the sector to some degree. They will overlap, but they'll depend on the sector. So for instance, as a sheep farmer in Wales, I know exactly where my sheep come from. I know exactly what all of the inputs are. I know exactly what I haven't put into the product, and therefore perhaps me testing my own product is of limited benefit for me personally. However, me testing the product may allow myself to access markets that I wouldn't ordinarily be able to access. In that I can provide my customer base with perhaps some additional assurance. So the isotopic fingerprint potential of my product can accompany more traditional paper-based traceability in order to kind of provide, objectively evidence effectively the reliability of that traceability information, and so there's a direct benefit there. I think also from a consumer's perspective, and therefore perhaps a retail perspective, you want to believe that you're receiving the product you think you're paying for. And there are two sides to that. Obviously, one, you just want the product you're paying for, and secondly, where that product is produced or originates potentially directly affects its safety. In so much as, again, in different production systems in different parts of the world, there may be different microbiological concerns associated with a product. There may be different contaminant concerns associated with a product, and therefore, from a retail or again a manufacturer's perspective, how can you adequately risk assess from a food safety perspective if you don't know where the product is from? So I think the benefit of doing this testing depends on the sector, but it's about assurance. It's about being able to adequately risk assess. It's about consumer confidence. It's about backing up traceability.
Gotcha. So if you were to pass, let's say, or as a farmer, if you're selling products into different target markets, is it possible then for the farmer to monetize more what he's doing? So to monetize the data, including the science, and actually add more value to the product so that the customers that are positioning their products in different markets, whether it's retailers or somebody that's exporting Welsh lamb, let's say, to Canada or to the US, that they could further monetize that data. Is there a potential there for farmers to embrace the science to be able to literally get more value and more money?
I think there's definitely that potential. I mean, time will tell, and obviously this is it's not necessarily a new technology, but certainly it's an emerging and growing technology in terms of its application and use, and so there's certainly that potential.
Gotcha. So I think what you're essentially saying, Mark, is that the evidence lies within the product, right?
Absolutely.
And we have to test to verify that, right?
Yeah, absolutely.
Yeah. So when you look at a specific product, can you talk about products that are relatively easy to do with the current science, and products that are difficult? You mentioned that wild caught fish is more difficult. Can you talk a little bit about the easy ones and also the difficult ones?
I think so. The data sets that we tend to have currently are data sets where where they're a representative perhaps of mainstream commercial production around the globe, and therefore that makes it a little bit easier to access the data sets in their first place. Obviously, anything domestic, we're based in the UK, so anything domestic is that little bit easier to get hold of from a reference material perspective. So anything kind of all agriculturally produced proteins, produce items, so your fruits and vegetables, just all of that side of things is pretty straightforward. A lot of commodity items, your teas and coffees and things like that, all fairly straightforward. Maybe harder to get hold of because of the geographic locations in which they're produced, and the variety of areas in which they're produced around the world. But that's time and effort, and but pretty straightforward in order to develop tests for those.
Gotcha. Now, Mark, you also mentioned reference databases, and I'm curious to get your opinion on reference databases. Is it that let's say all of the different laboratories around the world have different reference databases with reference samples? Do governments have them? How does that whole world fit together, and is there a need to pull it together?
So that's a great question. So in most cases, most laboratories have their own data sets that they have worked really hard on and invested in over periods of time, and there aren't really currently many mechanisms within which to share that information between laboratories. And actually, in a lot of cases, that's perhaps commercially sensitive as well, in that it's a business's own IP. Different laboratories will collect reference material in slightly different ways. We tend to take a quite forensic approach to it, as I think you'd expect. So, if I personally have stood on an abattoir line and can see a slap mark on a British pig, for instance, and I collect a sample from that pig, then there is absolute confidence that pig is from where it's saying it's from. There's a food forensics employee that's been directly involved in the collection of that sample. In other circumstances, we may allow a person who is independent from a producing business, such as a third-party auditor or something like that, to collect a sample. But again, our assumption there is that person is not directly connected commercially, I suppose, to that business, but there's always a chance of something that you can't predict. So again, we'll accept those into the data set, but perhaps at a lower confidence level. And there are also occasions where we will collect shop bought material, not because we're confident in where perhaps it's from, but because we know at a particular time of year, say, that material won't be from a target population that we're trying to be able to discriminate from. So obviously different laboratories may take slightly different approaches to that, and therefore the data sets are not necessarily completely aligned. Different laboratories are in different parts of the world, and therefore their customers may be asking them to answer slightly different questions. We at Food Forensics get a lot of questions, obviously, around is this a UK product, or is this, and therefore the data sets perhaps are aligned along those lines in order to meet the customer's needs. Whereas a laboratory in Australia, for instance, may be much more inclined to have strong data sets for Australian product. We will include things like that within the data, but be able to discriminate for the questions that our clients are asking of us.
Gotcha. So let me pose a scenario then for you, just to mine into this area a little bit more, and it's really around market surveillance. So let's say there's New Zealand lamb going into the UK, and Food Forensics is asked to do market surveillance. How would you go about getting the reference test to be able to verify that? Would you get it from the customer in New Zealand, or would you have to develop something yourself? Is there a level of interoperability there, or is it independent?
So in terms of, we will work closely and hand in hand with partner organizations in order to build appropriate data sets. So a great example is at the moment we're working with quite an international cheese business to develop data sets in and around cheeses of Greek provenance or Danish provenance or French provenance or Italian provenance, for example. And we're working with that business, but going up the supply chain with their help in order to target certain reference material, both milk and finished cheese. So it's all about strategic collaborations, really, I think, in some of these areas of in developing new tests.
That sounds great. So, Mark, what are the key challenges in this area? Obviously, the technology is improving at a very, very fast rate. But what do you see as the challenges? Are the challenges, for example, on the market adoption side? Are the challenges on monetizing this? Are there challenges in, let's say, the availability of laboratories or costs? Where do you see as the key challenges?
I think the challenges come in a number of areas. We've already talked about reference material collection, and that does present itself a challenge, as a challenge. Sorry, in that some products that you may want to target may be in really difficult to access parts of the world, and obviously to get the quality of reference material that we desire. Which in most cases means a food forensics employee or somebody being in that location. That in itself is a challenge, especially during a pandemic. It's difficult to get around and to places that you'd like to get to. I think adoption is definitely a challenge, but I think it comes from a place of businesses not quite understanding at this point how to use the technology and what the results mean. We spend a lot of time with businesses that we work on behalf of to try and support them through those kind of interpretation of results ideas. We're actually accredited for interpretation of results. UCAS accredited for that, so able to provide that additional support that helps them ask the right questions of their supply base in order to get to the bottom of an anomalous result. I think understanding of the technology from the perspective of a lot of people look at Syrah as a proof of origin test, which it isn't. It is a test for consistency with samples of known origin, which is a slightly different question. So I suppose challenges with that, again, link back to data set in so much as, profiles will change, data sets have to be constantly updated and refreshed and revalidated in order to provide the degree of discrimination that we would like. And again, I think the other key area here is knowledge about what test technology is out there in terms of adopting. It's not necessarily that people and businesses would not choose to use the technology if they even knew it existed, and that's a communication and marketing challenge for us as a business and the sector as a whole. In order to, they're quite specialist technologies. A lot of technical teams will be more than familiar with microbiological concerns and certain chemical tests, but this is a new and, as you say, fast developing area of test technology. So I think they're the key challenges for us.
Gotcha. So I want to go back to market surveillance briefly. I do tease CEOs every chance I get, and if I'm sitting down with a CEO or an executive team with a food company, and they, I ask them, do they export to X country, and if they say yes, I'll say to them, do you know that 10% of your products in that country are counterfeited? And their answer is, of course, John, how do you know that? And my answer to them is always, how do you know they're not? And that's my point on market surveillance. Do you think that companies that are shipping high value goods with high credence claims, organic, kosher, halal, whatever, if they're shipping those into the UK, is market surveillance important for them?
I think it's essential. They should want to protect their own brands and their own kind of reputations in that area, and all businesses are vulnerable to fraud at different points. Whether that fraud is deliberate or whether it's through lack of adequate process control. If you're handling multiple origins on a site, and a less than ideally trained employee makes a mistake and draws from the wrong material. It may not be that he's deliberately trying to mislead somebody, but from that business's customer's perspective, a mistake has been made and trust is damaged. So absolutely, I think businesses should be much more proactive in this area in particular. They should be more proactive in any area of testing, but particularly in this area where, as you say, if you don't know where a product's from, how do you know it's safe?
Exactly. And of course, one of the key drivers for these sessions is education on terminology being used. And I keep suggesting to the blockchain and other solution providers, not only blockchain, but other solution providers as well, that software cannot guarantee provenance despite the many, many claims. And I think there is some confusion in blockchain providers in particular when they talk about provenance. They're really talking in most cases about the data provenance, which is when the data enter the system, rather than what I call the scientific or true provenance, which is determined by analytical science. Do you have any guidance for the technology companies that are out there? Obviously, technology is critical for all of this, but as a scientist, as an analytical laboratory, what guidance would you give to solution providers?
I think the guidance that I would give is I agree with you wholeheartedly. I think technology has a major role to play moving forward in allowing better, more improved traceability systems. But I think to align that with test technology, where you can place an environmental fingerprint or a product fingerprint alongside a digital fingerprint, and one of them support the other one, turns that truly from traceability to transparency, and should provide really positive benefits for that business in terms of openness and allow them to really be positive about and really proactively kind of market the fact that they're not just suggesting where something's from, they can prove it.
Gotcha. Mark, any final words before we close?
No, I'd just like to thank you for the opportunity to talk about this area and offer that if anybody out there wants to discuss anything further or have any particular concerns, we'd obviously be happy to help.
Fantastic. Thank you so much, Mark. So, folks, there you have it. There you go. My recommendation, based on what Mark talked about, and based on some guidance I gave in December, is we have to start thinking more and more about food ecosystems rather than food supply chains per se, because the notion that we have a food supply chain most times talks about or implies that we have a linear supply chain. Supply chains are very complex and they're not linear. And moreover, we focus too much on the physical product, but we don't embrace enough the services that are required to bring that product to market and to provide evidence and, of course, enhance transparency and enhance trust. So for those of you that are out there that are producers, processors, retailers, or even technology companies, look broader than just the physical supply chain, as Mark talked about. Look at ways that you can embrace the science, embrace the evidence and the certificates, not only from the analytical laboratories, but also from some of the certification bodies, and integrate that into your platform. So think ecosystems. Mark, thank you so much for sharing your knowledge and wisdom with us today, and look forward to seeing you online.
No problem. Nice to see you, John.
Thank you so much.